So the salient features of this project are, it's going to be a 650-bedded facility with going to be made in 2 phases. The first phase is going to comprise of G+4 stories, and eventually 4 more floors are going to get added, so total 9 floors of structure. 24-hour emergency and trauma facility with 6 operation theaters, ICUs, NICUs, PICUs, and since the site is a very compact parcel of land, we don't have enough space for the luxury of expanding the footprint, so we have an automated MLCP facility to accommodate a parking for about 450 cars. It is intended to achieve a 5-star GRIHA rating eventually. Of course, needless to say that it will have all the universal accessibility features with extensive use of metropolitan art, and there's an extensive use of artwork in order to create healing architecture. We'll come to that. Incorporation of passive design techniques, use of new building materials. If the Jindal or the Kingspan team is here, I'm sure they will be more than happy to see this presentation because we are using a lot of Kingspan panels and the Jindal products in our project. And of course, we have done active solar installation on the rooftop, on the terrace, in order to harvest the solar energy for the project. So this is what the site looks like. It's basically a small piece of land, about 1.67 acres. To the north is the existing CNBC hospital across the road. To the left, on the west side, is a small parcel of land which is going to be used for education purpose by the government of Delhi. The highway, which runs from Akshardham to Gandhinagar, and the main road, approach road, is on the north, which gives access to the site. It is surrounded by residential activity primarily on all sides. These are the project requirements. So we have IPD, OPD, surgical suites, diagnostics, administrative services, and miscellaneous facilities. So that's the area statement. As you can see, the site is not very big, less than 10,000 square meters. So, and the ground coverage allowed is 40%, so we could not have more than, less than rather 4,000 square meters of buildable area on the ground. The total built-up area is less than 20,000 square meters, but the project cost is about 113 crores. So the concept basically is, based on having a sense of vision, which means that our design approach has to have a sense of perception, imagination, inspiration, creativity, modernity, and innovation. Now, all these words are self-explanatory. I don't need to emphasize on the definitions of them, but being an architect, it was inevitable for me not to talk about these concepts. So we have certain design essentials in place. We are looking forward to make an intelligent building which is based on healing architecture. Now, when I say healing architecture, it means that the design of this building plays an important critical role in the healing process of the patients, in the recovery of the patients, whether it is by means of creating a conducive environment, or creating art pieces in terms of murals, sculptures, landscape, spaces, and all those things. And then, of course, the buzzword of the day, that's green. So the building has to be sustainable. It has to have lower carbon footprint. Other than the design essentials, there were some planning essentials, like, for example, protection from unwanted and unnecessary disturbances in order to help speedy recovery, separation of dissimilar activities, control by strategically positioning the staff and the facilities, segregation of circulation of different user types, and distribution of services. We adopted an evidence-based design approach, which means to say that we invested a lot of time and effort in doing a lot of research, and based on the results of those research, we applied design solutions. Nothing was standard, nothing was based on thumb rules, it was all customized. And the reason was, a very brief peep into the history of this project. Actually, this one started around mid-June, or May or June of 2019, and that was the time when the there was a lot of demand for the healthcare facilities in Delhi NCR. And towards the end of 2019, by the time we were able to establish a reasonable amount of documentation, drawings, details of the project, the pandemic, the COVID, had started spreading. So in the middle of the process, the tendering had already happened by that time. By the time we could actually get the work started on the site, the government decided to convert this pediatric hospital into a COVID facility to cater to the aftermath of the pandemic. Now, the process is still on. They could not hold on to the construction activity. All the machines, the cranes, the JCBs, they were there on the site, ready to start digging any moment. And we did not have time to reinvent the whole process of design and start from the beginning. So the only choice was to accommodate the new requirements into the existing structural design that we had already finalized. So we did not have time. The COVID came. The first wave came in, I think, March or April 2020. It came and then it went. The second wave was anticipated in November, December. So by the time we were given a time period of 6 to 8 months from inception to execution to completely deliver the project, which was a big challenge. Had it not been steel, it would just not have been possible for us because conventional RCC construction, you all know, I don't need to tell you the advantages and disadvantages of both. So it is primarily the steel which gave us the advantage of converting the project brief simultaneously when the construction was going on. That's what the site looks like. To the north is the main approach road with the access to the main building. That's the main building zone. And an MLCP tower on the southwest corner with the services nicely and neatly tucked in one corner of the site. That's the peripheral movement that we had kept for the movement of the vehicles to approach the MLCP. The main entrance from the northeast side and the exit from the northwest side, the emergency entry on the north, the IPD, OPD entry from the middle, and the staff and the service entry from the southeast corner. That's the functional distribution of the building with the color coding you can see. So the wards very neatly and nicely tucked in between the admin block and the visitors entry at the bottom. The vertical circulation cores located at appropriate locations. So the key features of the project were a barrier-free movement, appropriate signage and wayfinding, a 3-point strategy that we developed in order to achieve the 5-star Griha rating for sustainability, which was based on 3 types of methods. First was the energy conservation, the second was the material conservation, and third was the water conservation. If we are able to achieve these 3 things, it invariably takes care of our primary goals of achieving a sustainable building with low carbon footprint. So certain passive design techniques that we are incorporating actively in this building, which are ice thermal cooling, heat recovery systems, free cooling and fresh air control systems. Needless to say that we have taken care of the natural daylight inside the building. We have done some calculations based on this. Like I said, it's a very evidence-based design approach that we have adopted. So all these algorithms, all these calculations have played an important role in achieving the Griha 5-star rating. We are actively installing the solar panels on the rooftop. These are the calculations that we have done. Solar water heating systems for bringing the water at a preheated temperature in order to feed it to the geysers to be supplied in various parts of the building. Use of materials like low E glass with different U values to bring down the heating and the cooling load. The cool roofs, which means creating stratas or layers on the rooftop in order to reduce the heat gain inside the building. We have a waste management strategy in place which takes care of all the waste management, whether it is organic waste, biomedical waste, recyclable, non-recyclable, solid, liquid. Water management strategies. So there is a strategy which we have in place that takes care of the water conservation. As you can see, there are certain things which have become inevitable, mandatory nowadays, having an STP, having an ETP, WTP, rainwater harvesting systems. So based on a consumption cycle and reuse of the water, we have done some calculations, and we have provided dual plumbing system in the building, and we are also using effectively water-efficient sanitary fixtures which use less water as compared to standard sanitary fixtures. Water-efficient landscaping, which means we are doing landscaping keeping in mind the flora, local flora, fauna, climate of the region, no invasive species of plants so that the consumption of water for the irrigation, for the landscape is least. And then, of course, use of artwork, as I said in the beginning, an extensive use of metropolitan art in different forms, because as most of you would agree, that colors inside the building, they have a stimulation effect. They have a stimulation impact neurologically on us as humans. Different colors have different impact. They ignite, they propel different kind of reactions when you look at them. So use of appropriate colors in spaces inside the building, outside the building. When you will see the images of the rendered images and the site images, you will see how the color schemes have been worked out in order to address and to achieve this goal. So these are the project details. I will very quickly run you through the plans. There's probably less time to go into the details. So this is the upper basement with the OPD section, the consultation chambers, and the waiting lobby for the patients and the visitors. On top of that is the ground floor with diagnostics in one corner, emergency in the other corner, and the medical support services in another corner. First, second, and third floors are typical, with the wards on one side of the corridor and support services, medical support services on the other side of the corridor. This is the fourth floor with the ICUs. Sorry, I think it's not readable. The text is a little blurred, but okay. That's the fifth floor with NICU and PICU. OTs on the sixth floor. Seventh floor is the service floor, which is going to be primarily used, as it is always used, for building services and medical services. Medical services like PTTs, pneumatic tube systems, pump systems for the medical gas. The seventh floor, which is going to be offices, admin, management, and eighth floor, which is partially built and partially a terrace, rooftop. That's the stack section that you can see. So on the ground floor, you just have the emergency and the diagnostics and the entry. Next 4 floors are the wards and the rooms, then ICUs, OTs, service floor, and the office section. This was, can you play this video here? Okay. Anyway, this was a concept video that we had made to describe how the working of the facade has been done in order to take care of the insulation, the aesthetics, the sound. So what you see here is, in the middle is all glass atrium part, the entrance part, which is about 4 floors high. The cores, the vertical circulation cores on either side, and these on the extreme left and the extreme right blocks are the insulated puff panels, the sandwich panels that are interlocking. So this entire scheme of facade was worked out keeping in mind 3 things. One was very, very fast construction, because like I said, we had this emergency of the pandemic, and we had to deliver this project within a time period of 6 to 8 months, and we did not have much time. So going by a conventional RCC construction and having a regular building envelope would have taken triple the time. So we did this elevation, we have done this building, the outer envelope, within a period of 2 months. So that's the connecting bridge which goes across the road on, to connect it with the existing CNBC building, the main hospital building, the rooftop screen to conceal and hide the services on the rooftop. This is eventually what the building would look like when it gets completed. Those are some of the rendered images to show how the building will look like. The insulated puff panels in the interlocking systems. That's the connecting bridge, the landscape below. The rear block. And that's the MLCP tower at the back in the rear, which is about 24 stacks high. So those are the site pictures. The building is underway. One thing that you might observe is the neatness and the cleanliness of the site as compared to a site which is having an RCC construction. Some pictures of the site. Yeah, so that was the main project. Other than that, these are some of the other projects which are where we are extensively using steel as a building material. This project, we won an award by the Union Minister, Honorable Minister, Mr. Gadkari, in 2017 for designing a solar-powered toll plaza. This is a prototype which is being developed by National Highway Authority of India in 4 different locations. And the concept was based on the principle of heliotropism, which is the principle of a sunflower. So just like a sunflower always faces the sun at every point of the time during the day, so this is going to be a very dynamic assembly, a permutation. Any point of time during the day when you drive through this plaza, when you come back after 2 hours, none of the configuration will be the same because it will be reorienting itself differently according to the new position of the sun. So we worked out some details for that. We've already submitted the detailed design report for this, and this is going to be built very soon. Some more projects. Zinc composite panels, metal hollow tubes for the louvers. This is the existing building, and this is eventually what it will become. Yeah, I think some more projects, but then they're all here to lay emphasis on the fact that we have to start using as much steel as possible because of its various advantages. Yeah, so that's it. Thank you.